Warm welcome to everyone. Thank you for joining our session. We are back once again in 2026 with a new session and a new topic for today. As you know, the whole idea and the whole motive behind this AWS User Group Data India is to talk about the innovations and things that's happening in the data field. We know there's a lot of buzz around with agentic and generative AI, and all those agents have been fueled with the data as a foundation. And that's where I've got interesting topic today, that how exactly you can leverage and scale tabular data on S3 with S3 tables. S3 tables were generally announced 2 years back at the reInvent. So we will be learning today with one of the specialists from AWS India to understand his observation on S3 tables, how exactly it's helping different customers, some of the use case and scenario. But before we kickstart around it, please join all the mediums. Like if you want to join, we have a WhatsApp channel, Slack medium, as well as LinkedIn and a meetup page. So you get an idea about what's happening new around this user group. So this is the new sequence of series what we are going to launch, and you will see every month we are going to come with new formats of it. And the whole idea is going to be virtual. So wherever, whichever part you are in the world, you can go through it. Best you joined live session so you are get all the answers queried, or you can talk to the speaker also. In case if you're occupied, you can also look all of these recordings on the YouTube channel of Data UG, which will get recorded on demand mode. And if you have any questions, we already have a blessings from our speaker that he will help you to answer it off the sessions. So with that, please don't hesitate to put your questions in the chat. I'll make sure that our speaker do answer it. And let me get our speaker on the stage. So today's for the session, which is stored tabular data at scale with Amazon S3 tables, our speaker is none other than Shubham. Shubham is an analytics essay at AWS India. And I must tell you, he's very knowledgeable with this domain. So you are in safe hands. And I would say ask as many questions as that this session of 1 hour get extends to 2 hours. Sorry, Shubham. I
Yeah,
will
no
end
worries. That's absolutely fine.
Exactly. So please ask as many questions. And with that, I will take a back seat and I will pass on the thread to Shubham so he can go and take the stage and just introduce us with the topic. So, Shubham, thank you so much, first of all, accepting our invitation to speak at our user group and give some
Mhm.
more understanding about Amazon S3 tables. I'll pass on to you so you can introduce yourself, and then we will kickstart with the session.
Yeah, definitely. So thank you so much, Sanchez, for giving me this opportunity, and thanks everyone for joining this session. So, hey everyone, my name is Shubham, and I'm working with AWS as an analytics specialist solution architect from last 5 years, and specifically working with ISV and startup segment from last couple of years to help them engage with the analytics services, help them to onboard on the Gen AI journey or the AI related stuff. Okay, so today I will be going to deep dive into the Amazon S3 tables, and we'll talk about that how exactly Amazon S3 tables are changing the organization landscape of storage, and how exactly it will help you to create a better data lake for your future perspective or for the future related architectures, right? Here is the agenda for today. So first of all, we'll talk about Amazon S3 tables, that what exactly the Amazon S3 tables, and first of all, why exactly we have the need of Amazon S3 tables. Then we'll talk about the basics and internals of Amazon S3 tables, that how exactly Amazon S3 tables works in backend, what kind of advancement it has to offer to the users, and why most of the customers or the enterprise customers started adopting S3 tables to make sure that they are able to scale their production workload by multiplying the use cases related to Gen AI, related to analytics, and related to any specific storage layer use cases. Right. Then we'll talk about some specific use case and workload where it would be relevant to use the Amazon S3 tables. And then basically we'll recap. Sorry. Then basically we'll recap the entire discussion which we had. Okay. So when we built Amazon S3 back in 2006, right? So we wanted it to be storage for the internet, right? To store all kind of data. It can be your videos, it can be your images, and it can be your PDF as well, right? That means customer can store videos, images, and other static content to power website around the world, right? Although this is very important use case for us, where most of the customer use Amazon S3 as an object based storage to store any kind of data, but later we find that there are many evolving use case over the time where customer needs more messes or need more technology basis orientation, that how we can store tabular kind of data as well, right? And this is where we saw the emergence of open table formats a few years ago, that actually helped provide a better framework to organize these data sets, right? Among these open table formats, like we have Apache Hudi, we have Apache Delta, so we have Apache Iceberg, and we have Delta Lake, right? So we have seen Apache Iceberg becomes a popular choice for our customers. So Iceberg basically adds the metadata files for you. It helps you to structure your data sets into tabular format, that basically the needs of the hour, so that your AI applications or your analytics use case will work better, right? Also, it provides you the functionality where you can do schema evaluation, time travel, and rollback kind of use cases. So initially, if we understand Amazon S3 just an append based storage, right? You cannot do DML kind of operations like update, delete, and time travel kind of functionality, which generally an transactional database provide, right? So to make object storage or enable object storage for these kind of features, we have Amazon S3 tables or Apache Iceberg in place, right? So if you notice, this is the way that we can query our Iceberg data stored into S3. All tabular kind of data is just a simple select star from table name, and you would be able to query your all unstructured data stored into your Amazon S3 tables, right? So now, as more customers adopt Iceberg, there are still some challenges they need to overcome to make sure that their data lake is operating efficiently and securely, right? So the first is performance, where Iceberg has made it easy for multiple applications to safely work on the same data sets, but this means more applications are accessing the same data set, which has increased the baseline request traffic demands needed to support all these kind of workloads as data scales over the time, right? So as these applications also continue to operate with the same expectation or performance, which means you also need to invest in maintenance activities such as compaction, snapshot retention, and orphan file removals over the time, right? So basically, in short term, if I talk about Amazon S3 tables, it's basically the managed form of Iceberg tables, where you don't need to run any operational activities from your side. It's all everything is maintained by AWS related to all the operational activities, so that you can focus on your actual analytics use case. You can just focus on your data set, which will help you to enable the analytics and Gen AI use cases for your organization. Yeah. So with S3 tables, you will get up to 10 times the transaction per second out of the box compared to the prefixes in general purpose bucket. So as you have seen S3 general purpose bucket to store your data, and we know that there is some transactional limit we have there, that is 3,500 and 5,500 for your read and write requests, right? But as we understand that Apache Iceberg tables used by multiple applications, multiple Gen AI use cases, where we need to scale the throughput as well for this, right? So that's where we are providing 10 times TPS for your transactional data lake, so that you can achieve or you can run multiple concurrent application at once, and able to utilize this Apache Iceberg as an analytics layer for your use cases, right? Also on top of it, like I mentioned, that Amazon S3 tables provide you all the operational activities like automatic compaction behind the scene, automatic snapshot retention, and automatic orphan file removals, so that your data will provide you the better performance over the time. Okay, so as we are discussing about the operational activities, but why even we require that, right? So first of all, what happens that whenever we use Apache Iceberg or Amazon S3 tables as an open table format for our storage layer, for each kind of operation we run into the data lake, that can be your insert operation, that can be your delete operation, and that can be your update or upsert operations, right? All these operations creates a file every time whenever you run any command, due to which it creates multiple smaller files in the backend, and also it creates huge amount of metadata for us, right? So to make sure that our data lake will perform better for all kind of use cases, that's where we have a requirement that automatic compaction comes into the place, where it will convert all your small files into one larger file to serve your analytics use case, right? As we know that analytics engines require at least 128 MB of the file in backend so that it provides better performance over the time. And that's where we have this automatic compaction, for which initially customer needs to run the compaction process manually, either running a different compute resources, or they need to maintain everything from their self, right? But using the S3 tables, we are providing automatic compaction out of the box. So as a customer, you can only focus on how to read this data and how to perform the analytics and GenAI use cases on this data, instead of worrying about or periodically running your compaction, snapshot retention, and orphan file removal process, right? So as we understand that the less number of files we have available in S3, it we will have less number of requests comes to the S3, and that's where we can scale our applications as well, right? Okay, now the second most important perspective for the organization is that how we can achieve the governance for our S3 tables, right? As governance is one of the important topic for the organizations, specifically for enterprise organization, because security matters, right? Then how we can control the correct access should be granted to correct users in the organization, so that specific entities or specific group of users would be able to access set of tables, right? That's where we have simple IAM role related policies for the S3 tables, which you can place and able to utilize your S3 tables the same way you are creating the policy for your S3 table, S3 buckets initially, right? So over the time you are updating these updates. Like I said, that you will run multiple insert operation, multiple update operation, and multiple upsert operation for your data lake. That means you are generating a new snapshot that reference new data files, right? As a snapshot is something which provides you the time travel functionality, so that you can time travel to the previous state of the data. This is also a very important use case for the organizations who would like to audit their data sets over the time, right? Because we have the requirement where, let's say, if someone in the user or in the production, they have accidentally deleted some data or accidentally updated some data, right? So generally in the data lake world, we don't have any option where we can go back to the previous state of the data. But using these open table formats, you will get an option where you can roll back to the previous state of the data. Or let's say if I would like to see that what exactly the state of data 4 days back or 5 days back, or let's say 30 days back, right? So I can verify, or I can fetch all the data, or what was the data state of the data, I can verify, or I can fetch it using Amazon S3 tables, right? Now let's understand that what kind of workloads we can run on S3 tables. As we have covered Amazon S3 tables, and now we understand that what exactly and what extra S3 tables are providing. But let me recap it again so that we can further talk about the workloads on S3 tables. Like I said, that S3 tables is nothing. It's just the managed iceberg table on S3 bucket. That means the tabular S3 bucket kind of storage you can find. And after this S3 tables, just not so it is providing you all the operational maintenance activities from AWS S3 table side, that you don't need to run compaction, you don't need to run snapshot retention, and you don't need to run orphan file removal. All the operational activities will be automatically handled by S3 tables in the backend. And apart from that, you will get 10 times throughput for your, or 10 time transaction per limit for your S3 prefixes as well, right? That means you can use more number of applications to access the same data without even any throttling. Now let's talk about some examples workload where you can run S3 tables, and we can see in the architecture side that how we can run the S3 tables, what kind of analytics tools, what kind of AWS services we can leverage for the Amazon S3 tables. Right? So here, if you notice, in the left side, we have Amazon S3 tables, which is our tabular bucket. And in center, if you notice, we have AWS Glue Data Catalog, which is our central metadata repository to provide you the catalog for the S3 tables. Right? In the right side, we have all AWS Analytics services in place. That is Amazon EMR for the data processing to process petabytes of data from one storage engine to the another storage engine. Or you can do certain kind of transformation as well using Amazon EMR. So you can use Amazon S3 tables with any piece of analytics services for your use cases, right? Now, Amazon S3 tables provide you the REST API as well. So you do not need to rely on any specific AWS services. If you would like to use Amazon S3 tables outside of your AWS account or outside of your AWS use cases, you can use the simple Amazon S3 tables using the REST API method. That's what the beauty of Apache Iceberg is, that it allows you to access the data outside of AWS Analytics services as well using the REST API, right? After that, like I said, that one of the important use case or perspective for the organization is that how we can control or how we can make sure that we have correct governance in place, so that we can do the fine grained access over the data, we can control the permissions for the tables and databases created in my data lake, right? That's where we have this integration with AWS Lake Formation, which is our data governance service, allowing you to provide the access for your tables and databases. So using the same service, you can control the permission for your Amazon S3 tables as well. But if you do not would like to use AWS Lake Formation, then you can use IAM rules as well for your S3 tables, right? And once you provide the correct set of permissions to the users, only those users will be able to access the table either using Amazon Athena, Amazon Redshift, or Amazon EMR as a service, right? So this is what the S3 tables catalog implementation we have in place, where it allows you to directly call the Amazon S3 tables using REST API, so that you can query your data using the REST API endpoint and without configuring anything in the backend. And even you can access this data directly using open source tech stack using Apache Spark, Trino, any kind of open source services which supports Apache Iceberg. You can use Amazon S3 tables with the analytics services, right? This is one real-time analytics use case we have, where let's say you have certain kind of data set generating in real time in streams. It can be your MSK streams, that is managed service for Kafka or Apache Kafka, and you can have data set or you can have real-time stream in Kinesis as well, right? So after that, we can use Amazon Data Firehose, which is our managed service to process the streams, and it can generate your S3 tables automatically out of the box on your streaming data as well. And further, you can visualize this using Amazon QuickSight to get the insight in real time, right? So this is what the architectural flow will look like, where you have the streaming data. After that, you have Amazon Data Firehose, where you do not need to write any set of code or any set of programming instructions. You just need to provide some set of configuration, that where exactly your stream is and where and on which S3 table bucket you would like to write the data. Once you provide these configurations, you would be able to write the data into your Amazon S3 tables bucket. And after that, you would be able to visualize this data using Amazon QuickSight in real time, right? So that this is really wonderful, that where organizations have these kind of use case, would like to visualize the data in real time. This where this real time analytics will come into the picture, and out of the box, without maintaining any pipeline behind the scene, all these AWS managed services without any operational overhead, you would be able to utilize or find the data insights in real time, right? So that's it related to the Amazon S3 tables, that where exactly it is useful, why we have the need of Amazon S3 tables. As we understand that over the time, operational databases becomes really expensive. We can't use operational databases for our analytics kind of use case. That's where we have the need for open table format, where we can have a data lake and we can run the transactional kind of operations like asset properties or kind of insert update delete kind of operation on our data lake, so that we can effectively scale our analytics use case with cost effective solutions, right? On top of that, plain Apache Iceberg does not provide you the operational activities like compaction, and snapshot retention and orphan file removals. For that, Amazon S3 tables will provide all of these functionalities out of the box, that you do not need to look into it, and everything will be managed by Amazon S3 tables in the backend for you. And it also provides you the 10 times throughput, which is really important for applications or for multiple applications in organization if you are using to access the Amazon S3 tables data, as we have the certain limit on the prefixes related to the throughput. So that will allow you to scale your workloads 10 times automatically out of the box, right? So that's it related to the theoretical part, that what exactly S3 tables and where you can use the Amazon S3 tables for your use cases. Now we'll move to the hands-on lab. Let me know if you have any questions so that we can discuss, and then we'll move to the lab directly.
So, Shubham, there are two questions from Abhishek Yadav. Does this
Uh,
also have a storage class as we have in general purpose bucket? And the second thing is it a global or a regional service?
so basically, is it a global service, right? The global is related to that the naming we have available for the Amazon S3 tables, right? But again, it's specific to each region as well, where it stores your data. So for the naming wise, it's a global one, but how exactly you will store the data, it's regional only. The same way you have Amazon S3 as an object-based service, the same way you have Amazon S3 tables. So
And
for
I think,
storage purpose, it's regional. Yeah.
yeah, and there is, I think, the first part. How does this also have a storage class as we
Yes.
have in general purpose bucket?
Yes. It allows you, even it has this automatic tiering as well, where on basis of frequent data access or non-frequent or infrequent data access, it will switch the classes automatically in the backend. It has this functionality and you can use it. Okay.
Yeah, those.
Any other questions we have?
No, I think those were the questions. I think we can switch to the lab part. And also, I think there's one more, sorry, from Abhishek itself. So if a table is
Mhm.
created in US East one, will user in EU Central one can experience some latency?
No, I wouldn't say they will experience some latency, but yeah, definitely there would be the cross region charges would be applied, right? That's where we always suggest customer to use the same region data access if it's possible. If it is not, then definitely the cross region charges would be there, but latency will not come into the place for that.
Yeah.
Okay, now let's move to the hands-on lab, where we'll see that how easily we can create them as on S3 tables. So to make the session easy or to make the workshop easy, we'll use the interface approach. But you can, for the production workload, you can use cloud formation, you can use SDK and go to 3 API method to create them as on S3 tables to configure your Amazon S3 tables, right? Uh, so first of all, let's navigate to the Amazon S3 console to see that how we can create an Amazon S3 tables. Right, so here if you notice, we have this table bucket option in the left side. This is an additional options we have available. So here you can create on create table bucket. Here you can provide your table bucket name, whatever the table bucket name you would like to provide. Here one important point you need to remember: whenever you are creating the table bucket, you need to make sure that you will enable the integration so that all other AWS analytics services would be able to access your S3 tables data. Right now, once you scroll down, if you notice that someone has mentioned how if we can switch the storage class, so definitely it has intelligent tiering, where it allows you, where it will automatically figure out that whatever the objects it is not using behind the scene for the longer time, it will automatically
Shubham,
switch to different
sorry.
classes.
Sorry to
Yeah.
interrupt. I think your screen is currently the presentation itself, not the AWS console. If you can
Okay,
switch.
okay, sure, let me just quickly change it. Okay, can you confirm now is visible?
Yeah, we can see your screen now. Console,
Okay,
AWS console.
perfect.
Yeah.
Perfect. Let me just recap again or revise again what we have discussed. So first of all, what you can do, as you have Amazon S3 as a service, you can navigate to Amazon S3 service, and here in the left side you will find the table bucket option, right? You can go to the table buckets, and here you will get the option to create table bucket. But like I said, that to make this workshop easy, we'll use the UI interface, but you can simply use your CLI, AWS SDK, or Boto3 API method to create this bucket, right? So here we can use create table bucket. Here we can provide the table bucket name. After that, one thing we need to remember: whenever we'll find the option to integrate with AWS Analytics services, you need to enable this integration. So your all AWS Analytics services would be able to access the Amazon S3 tables data automatically, right? After that, we have the storage class option. So if you do not specify anything, by default, it will go with the storage one. But if you would like to save cost, or if you would like to make it cost effective, you can go with the intelligent tiering option, where it will automatically change the tiering of your storage class on basis of your object access, right? After that, you can simply create on table bucket. And once you create on table bucket, it will create a table bucket for you. And this is kind of table bucket ARN you will get here. So this is something similar like Amazon S3 bucket only, but here you will not be able to see your data, the data which you are storing. Everything will be automatically managed by AWS behind the scene for you. Okay, now let's see that how we can create an S3 table bucket and how easy it is, right? For that, let's navigate to Amazon Athena. Like I said that we will use the UI interface for today's session. So to make it easy, so here we have Amazon Athena as a service. So Amazon Athena is our interactive analytics services, or for the ad hoc query, where you can run your interactive query without provisioning any server. Automatically behind the scene, it will create it, it will execute your queries out of the box, right? So here you can use the query or data in Athena console, and you can select launch query editor, right? So this is what your Athena console will look like. Now again, you can navigate back to your table bucket, and here you can click on table bucket. Here also you will get a direct option or shortcut option to create a table with Athena, right? You can click on it, and here it will allow you to create a namespace, right? So this namespace, you can think of something like schema kind of interface, where you have a hierarchy, where you have database, schema, and then table name. Like the same way you have S3 bucket, then you have namespace, and then you have your data stored, right? So let me create a namespace here. This is what my namespace, and I can click on create namespace, right? Once I create namespace, it will allow you to create a table with Athena, right? So instead of directly going to the console, you can even go from your S3 console as well, right? So as we know that Amazon Athena require you to set up the output location first. Here it will give you the pop-up as well that you first need to set up a query result location in Amazon S3 so that you can run your Athena queries. As we know that once Athena execute the query, it will write the data to your S3 bucket, and from there it will fetch the results for you, right? So let's set up an S3 bucket output location, right? Here you will get the query result location option. You can click on manage, right? Here you can click on browse, and here we have only one bucket available, but according to your organization structure, you can select the S3 bucket where you would like to write the output data, and I can select it, and I can click on save, right? Once I click on save, now Athena will allow me to run the queries, right? Let's navigate back again to the Athena console, right? And create a simple table. As we already, so if you notice, it has created a default template that how we can create the S3 tables. But let's try to create a new table for this lab. So if you are familiar with normal SQL command or NC SQL command, you would be able to access or work on Athena or work on Amazon S3 tables very easily. So if you notice the syntax, it's same like your SQL syntax or the Athena SQL syntax we have. That is create table command. After that, we'll provide some column names. Then the partition by to make sure that we'll only scan the limited amount of data what we need to scan. And here we just need to make sure one thing: whenever you create an S3 tables or iceberg table, you need to mention the table type is iceberg, right? This is the only add-on property you need to pass. And once you provide this, you can click on run, right? And it will create the table for you. Let me close other query tab. Yeah, so now it has created the table for me. Now let's try to add some data into this table. So there are multiple ways to add the data. You can add the data from your existing normal S3 table, normal Athena table to the S3 tables as well, or you can simply use the insert into command for that, right? So if you notice, it's a simple insert into command with the column values. Once I execute this command, it will create an Amazon S3 tables with some data set for me, right? Now we have S3 tables created with some data set. Let's try to query this data, right? Now if you notice, I'm able to see my data. This is the data which we have created using the insert into command. right? Now let's say if I would like to update the sales amount for my laptop product category. So if you go to your general Amazon Athena tables, you will not be able to update this amount, right? You need to rewrite the data or you need to override the data for this, the entire data. But using Amazon S3 tables or using Apache Iceberg as an open table format, it allows you to modify your tables as well, which is created on top of S3 bucket, right? Let's see how we can do that, right? So let's try to execute a normal update command here. Let me just remove this cell. So if you notice, it's a simple update command, update table name, that is sales amount equal to 1000. Currently we have sales amount 900. We are modifying the sales amount to 1000, and where the product category is laptop, right? A simple SQL query to modify my data. If I run this query, right, it it has executed successfully. Now let's try to again see that if it has updated the data or not into my S3 tables, right? So here if you notice, now my laptop product category price updated to 1000 rupees. Initially it was set to 900, right? So if you notice, with the simple SQL commands, you will be able to update your data lake data as well using open table formats like Apache Iceberg, right? The same way you can run other DML commands, like let's say, I would like to delete some data from this table. Let me delete it as well. So where product category equal to keyboard, I don't want this data anymore in my data lake. I would like to delete it. So I can just simply run this delete from table name where product category equal to keyboard, right? It has deleted the data successfully. Let's verify it if we have keyboard data anymore in the table or not. And here if you notice, we have keyboard data deleted, right? Now we have only 3 rows. Initially we have 4 rows in the table. Okay, so if you understand from this is the way you can convert your normal data lake or normal data lake table into the transitional data lake. That means it allows you to run all the kind of asset properties, all kind of databases operations like insert, update, delete on your object storage, which is very cost effective, right? So for all your analytics use case, where if you are still running your analytics use case on your operational databases, it's suggested to move your operational databases data to storage bucket, that is Amazon S3 tables, and further you can leverage all the operations using cost effective storage method by Amazon S3 bucket only. Okay, so now we are able to run all these operations, but if you remember, we discussed about one more functionality, that is time travel. What exactly it means by that? Now I have updated some data, that is the sales amount I have updated to 1000. I have deleted one row as well, that is keyboard row, right? But as an audit, I during the audit I would like to verify what was the initial state of my this data, right? So using Iceberg we can do it. So using Iceberg, it provides you the snapshot approach to roll back or to go back to the previous state of the data, right? Let's see how to do it. So what you need to do, again, if you notice, it's a simple SQL query, not any overhead command you have to run. So after the select star from table name, you just need to add an utility $snapshot, right? It will list all the snapshot which is created for this table, right? If you notice, we have some delete operation we have executed some update operation, and we have executed one insert query. That's why we have 3 snapshot available. So for your each operation, it will create a snapshot so that you can time travel to the previous history of the data, right? Now what we can do, we can navigate to the previous state of the data. So let's say I would like to see what was the state of data when I first created this table, right? So what I can do, I can copy this snapshot ID, right? And let me just paste it here. And now let me just reiterate the command again, that is select a star from table name for version as of this first snapshot ID, right? So it should show me 4 rows, and the laptop price should be 900, not 1000, right? Let me run this. Here it is. If you notice, this is the first state of our table where we have initial price was 900. We have one keyboard row as well, but in the current table we have updated it according to the use case, but still I'm able to verify that what exactly the initial state of my data. Okay, let's verify the current state of the data again. If we run this command again, that is select star from table name directly, you will notice I am still able to see my current state of the data where laptop amount is 1000 and one row is already deleted, that is keyboard row. Right, so this is the advantage of using Amazon S3 tables in the production, and that's why most of the customer are using Amazon S3 tables, where they would like to get the functionality of transitional data lake instead of a general data lake. Right, so if you have a use case where you have upstream applications creating lot of small files, you need to run the compaction operation manually, or if you have a use case where you have to frequently run the override command in your organization, it's suggested to go with Amazon S3 tables, where it will provide all the transactional data lake capabilities for you. Okay, not only this general append table, not just general delete update command, you would be able to add more columns as well. Right, so let's say today for this data I have only 3 columns and I would like to add one more column. Can we do it? Yes, we can do it. So what we can do, again a normal SQL query we can execute, that is, let me just remove it, that is alter table table name add column city string. Right, if you notice, to work with Amazon S3 tables is quite easy because it provides you the SQL kind of interface to execute the queries. Now let me add this column. Right, now let me again verify my select star. So initially I have only 3 columns, but I have added one more column, that is city, and if you notice I have city column updated. Right, so this is the advantage using for which most of the customer prefer to use Amazon S3 tables in their organization now. Right, the same way you can drop the table as well. So let's say if I would like to remove this table from my data lake entirely, I can just simply run the drop table command and it will drop the table for me. Right, now I have no table available here. Right, so this is the easiest way to start with Amazon S3 tables, where you can start a POC or where you can start general hands-on exercise with the Amazon S3 tables by navigating to your test account or by navigating to your staging account, where you can create an S3 table bucket using Amazon S3 console. After that you can use Athena to execute the queries without provisioning any resources. Okay, so this is one of the way to access or create the Amazon S3 tables, but you might have, or you must be thinking that what if we need to work with huge amount of data, right? How we can do it, how we can ingest the data from different data sources, or let's say I have some CSV or Parquet files already stored in my S3 bucket. How can I convert this data into my Amazon S3 tables, right? So that is also possible. Either you can use Amazon Athena, or there is another very famous data processing tool available in market, that is Apache Spark. You can use to read some data and write into Amazon S3 tables and perform certain kind of operation. Okay, let's just quickly see that how we can do it using Apache Spark. Right, so for that we have AWS Glue, which is our serverless service, uses Apache Spark in the backend. Right, if you notice, all the AWS analytics services are based on open source services itself, so it's very easy to understand, it's very easy to find any kind of specific document for these services. Right, so here if you notice, we have this AWS Glue console. Now if you go to the ETL jobs, you can create an ETL job where you can read the data from some S3 location and write into Amazon S3 tables. Right, here let's go with notebook option, which provides you to run the interactive kind of queries here. Right, here select the IAM role. So we have AWS Glue service role available. Let's select it and click on create notebook. Right, this is the same Jupyter notebook kind of concept, which allows you to run your queries interactively or run your code interactively. Right, it is specifically used for the development purpose, or most of the data scientists prefer to use Jupyter notebook kind of interface because it's easy to understand your code, it's easy to understand or develop the functionality here. right? It will take few seconds to start with the notebook side, but once we have the notebook ready, we can simply use the Spark job to create an S3 table, right? So here if you notice, we have some certain code generated, but let's use our own set of code, right? Let me configure the environment for S3 tables first. So if you notice, this is the general settings to configure my environment, that what would be the number of workers, what would be the worker type I would like to use. And then I want the data lake format as ISPA, right? Let me run it and it will execute the cell for me, right? Now this cell has executed. I need to configure my S3 tables related properties here. Right? Let me remove this default code and just set up the S3 tables related properties. This is just one time activity you need to do, and it's very easy to do it, right? This is what available in all the documentation. You just need to use and copy paste. And here you need to update the properties according to your table bucket name. So here I'm using reason US East 1, right? So I can update the reason to US East 1, right? And I need to provide my table bucket ARN. So how we can find it? If you navigate back to your S3 tables, go to the table bucket, and here we have the ARN available, right? So from here you can take the ARN. This is one property you need to change, and everything remains same. So you need to provide your ARN, right? And then here one reason as well you need to update, that is US East 1, or update according to your reason, which reason you are using, right? Once we update these three property, we are good to start with Amazon S3 tables, right? So if you notice, it has created the environment for me, right? Now in the backend, it is provisioning the resources for Apache Spark, because it is a distributed processing engine, require a cluster to run in backend to process huge amount of data, right? So right now I'm starting with 5 nodes, where it will create 5 virtual machines for me in the backend and set up the Apache Spark on top of it, right? This activity will take again barely 30 seconds to 50 seconds, and after that you can start with your job, right? Meanwhile this session is creating, let me add some variables as well. So I'm just defining some variables, so I don't need to manually update variables in my code. So here I have set up the catalog name, which catalog I would like to use. Namespace we have created earlier, you can find it from your S3 table console as well. And this is the new table name I would like to create, right? Let me run this code. Now I have set up the variable. Now let me read the some Parquet data from S3 location, right? So that I can convert this data or create an S3 bucket out of it, right? So this is the way I can read the data. That is some Parquet data I have stored, and I can read this data. So it's some huge set of data, due to which it is taking some time, right? So if you notice, I have loaded some data set which has number of records 30, 50, right? Now again, I just need to simply I can use the SQL command in Spark as well, like create table, table name, all this. And then again, the same way we have provided the Athena command, I can provide the Spark SQL command to create a table, right? So one good thing with S3 tables is that if you know SQL better, you would be able to use this feature very easily, right? So here if you notice, I'm simply creating a create table command and then creating a table for Amazon S3 table, right? Let me execute this.
Uh, Shubham, if you can zoom in a bit on the console, I think the
Oh,
query is a bit small in the size.
yeah, let me do that. It is fine,
Can you
right?
zoom in further, if possible.
Okay, sure.
Yeah, that's great. Thank you.
Right. Okay, so let me just again revisit the commands which we have executed. Really sorry for the font issue. Okay, so here if you notice the same way, this is just one time Spark configuration you need to pass here, right? So where you just need to update your reason and your ARN for your S3 table bucket, right? That's it. Once you update this property, your environment will be configured to read or write the data from Amazon S3 tables, right? After that, I'm setting some variables so that I don't need to manually update the variables again and again in the code. And then I'm reading some data from S3 location. I have some Parquet data stored, and I would like to convert this data into my transactional data lake, that is Amazon S3 tables, right? Once I am able to load this data into my Spark data frame, after that, I'm simply using some SQL command to create my iSpark table or create my Amazon S3 table, right? If you notice, the syntax remains same. The same syntax we have used in Athena, the same way we are creating a table here as well, right? So now it has created this table for us, right? After that, let me create a view on top of it so that we'll be able to read this data, that what is the data available into my Spark data frame, right? Now the view has created. Let me read this data using this view. So if you notice a simple Spark SQL command I am running, let me just provide the select star from table name command to read the data from my S3 tables. And here, if you notice, we are successfully able to load the data into S3 tables as well, right? So this is another way to read and write the data into Amazon S3 tables. You can use Athena, you can use Apache Spark, that is our AWS Glue and EMR service, to read and write the data into S3 tables. Okay, even if you have created the table from here, you would be able to query the same table using Athena as well, right? Here, this is the namespace we have created. If you notice the new table which we have created, it's visible here. We can query the same table using Athena as well. That is select star from table name, limit 10, and I'm able to see my same data. Okay, so that's it related to the Amazon S3 tables. We have discussed in this session today that what exactly Amazon S3 tables is, how we can read and write the data using different analytics tools, and I'm sure that now you find it really easy and definitely will do hands-on on some test account or in your testing account, that how to create an S3 table, how to read and write the data into S3 tables, and how we can run all these transactional commands into your S3 tables. Apart from that, like I said, that all the operational activities related to your compaction, related to your snapshot file retention, and related to your orphan file removal will be taken care by Amazon S3 tables out of the box. So you don't need to worry about it. You just need to work on your actual use case, and everything will be taken care by AWS itself. Okay, so that's it for the session today related to the hands-on side. Let me know if you have any questions. We can discuss it.
Thanks, Shubham. That was really interesting. And again, the demo is always great from a learning perspective.
Mhm.
Absolutely, there is a question from Farhan. Recently, the size of the S3 buckets has been changed. What is the maximum size currently it supports?
I believe it's 10 TB, but need to verify again. We can look into it. Yeah. But as long as for your analytics use case, you will not find or you will not hit this limit anymore, because that is more like how much part of the data you can store, or in how much part you can store the data. So that will not hit you. Yeah, but it has recently updated.
Correct. The second question is also from Farhan, a request. Is it possible to share the demo or workshop, whatever the scripts you have shown? Is there anywhere they
Mhm.
can, maybe from a GitHub, gist or something with?
Yes, definitely. So this is the workshop available online as well. You can just search Amazon S3 tables workshop, or this is the link you can use to access the workshop. It's available for everyone,
If you can
and you
share
require
that
the
link,
test account.
yeah, if you can share the link with me, I can put it in the chat.
Yeah, yeah,
Uh,
I have just added
or,
in the chat.
oh, great, awesome. Uh, can we see the data set you created in QuickSight? I think that's a question from Abhishek.
Yes, definitely, definitely. We can see it, although it requires some set or it requires some steps to visible. But let me uh, show you here in the workshop itself. So if you get the time to go through this workshop, here if you notice, we have one more lab where you can visualize the data using S3 tables. And one good part using Amazon QuickSight is that you don't need to create the chart manually. Here you can run your natural language queries directly, like create a pie chart for total user ID by browser type, right? And it will create a chart for you. So answer is yes, you can use Amazon S3 tables with QuickSight as well. If you remember in the PPT, I showed you that you can integrate with different AWS services. So yes, QuickSight is one of them.
And yes,
And
I've just put the link of the workshop in the chat. Thanks, Shubham, for that.
yeah,
Please, we have a couple of more minutes, so please put your questions in the chat, and we'll be happy to answer all of them.
okay. Do we have any other question?
No, I think we are good. So with that, we are here to the end of our session for the month of the March. Thank you once again, Shubham, for joining us and spending an hour from your weekend to help our user group community to learn about S3 tables. I'm sure we are going to have many more sessions in the near future. And thank you everyone who has been watching from an hour about this and trying to learn from Amazon S3 tables. Again, the links for the workshop I have given in the chat, so please go through after the session. The video will be live on YouTube channel, so you can go through and look at the demo. The codes are already given in form of the workshop. So please try, practice offline. And I'm giving you 4 weeks to practice this before our next session. So yes, our next section will be in April, in the similar mid-April timeline. So stay tuned. Please subscribe to our data user group meetup or WhatsApp group, so you're tuned with the new announcement out there. With that, we take a leave and we'll see you in the next session. Thank you once again and stay safe. Thank you.
Yeah. Thank you, everyone.